Hi everyone, we're talking about angles, specifically angles used in trigonometry. A lot of times you will see angles that are within a triangle and then they have to follow all the rules of triangles. But we will also see angles that are outside of triangles, essentially just out in space on a plane, usually an XY axis. An angle is made up of two basic components. Both of them are rays. We have a ray starts in one point and goes on forever in any direction it chooses. What we have here is one ray called the initial side, and we have another ray called the terminal side. And if you imagine that this angle can be turned around like so, that means it can always be kind of situated and oriented in a specific way. And the initial side of the angle will always be located like this. It will always be a horizontal ray pointing to the right. Right? If you think about an XY axis, X and Y here, the initial side of the angle is always going to be on the positive side of the x-axis, right? That's where the initial side is going to lie. And I will abbreviate this with the letters IS. The other ray that makes up the angle is called the terminal side, and I will abbreviate this with the letters TS. So the initial side has properties that it is fixed and always facing to the right, horizontally. Right, the terminal side is much more free to move around, but it moves around in a specific manner. If you think about the hands on a clock, that's how the terminal side is going to move. Right, so once again, if we draw a ray pointing straight to the right, this is the initial side of an angle. If we think about a ray that is pointing anywhere else, but coming from the same point of origin, then this is going to be the terminal side, and this terminal side is going to be able to be rotated, again, like the hands on a clock are rotated. Right, so it can move, and based on the degree measure, it will stop somewhere. Right, so the measures of the angles are going to be measured in degrees or radians. We'll talk about radians later. But it's always going to start where the initial side is located. And then from there, it's going to move. If the degree measure is positive, let's say positive 90, for instance, that means that this angle swung in a counterclockwise manner, starting from the initial side. If it's, something like 120 degrees, then it will end up over there, and it can end up over down here if it's past 180 degrees. And then if it's something like, 316 degrees, 349 degrees, then it will end up over here. But usually we don't see this thing swinging. We see the angle after it's already done moving. Right? So the measure of this angle tells us which way that this angle moved. right? If it moves in a, let's say, a negative 90-degree angle, that means it started here, swung down in a clockwise fashion, 90 degrees, and ended up right over there. Right? If it moves negative 180 degrees, that means it ended up pointing straight to the left. So let's look at a 90-degree angle. Right? And we can resize this. We can move this down so it doesn't interfere with that writing. Okay? So let's take a look at this angle, which is 90 degrees. That means that it started at the initial side and ended up coming straight up. Well, what if it did this? What if it started going and ended up at negative 270 degrees? Again, based on the angle, whether it has a positive or negative angle that is told to you, it doesn't really actually matter whether this thing is judged as a negative 270-degree angle or whether it's judged at a 90-degree angle. Right? All we really care about in terms of the values of sine, cosine, tangent, and things like that is where the terminal side ends up. Which brings us to the topic of coterminal angles. Right? Coterminal angles are angles with the same terminal side. Right? For instance, if I were to draw an angle that measures 60 degrees, right, that means it started on the initial, the terminal side swung in a counterclockwise direction up 60 degrees. Well, if I were to take another angle, and let's go 420 degrees. 360 degrees is a full circle. So if we go another 60 degrees over there, past 360, that means the terminal side ends up here. As far as trigonometry is concerned, these angles are exactly the same. Now, if we take, again, an angle that starts on the initial side, and let's move it negative 300 degrees, right? So negative means that it started on the initial and moved in a clockwise direction. Right, so negative 300. Well, that means that it ended up in the same place as the 60-degree angle, right? Because if you move counterclockwise by 60 degrees, or if you move clockwise by negative 300 degrees, this terminal side ends up in exactly the same place, right? So the angles that have the same terminal side, again, remember the initial side always stays fixed. That means the terminal side is in the same location. These angles here, 60, 420, negative 300, are examples of coterminal angles, again, because their terminal sides are in the same location. And coterminal angles are always going to be 360 degrees apart, or 720 degrees apart, or maybe 4 revolutions of a circle, 1440 degrees apart, right? An angle that starts on the initial side and goes 1, 2, 3 revolutions, and then another 60 degrees past that has a terminal side that ends up right over there. And this is an angle that measures 1,140 degrees. Again, same angle as far as trigonometry and sine, cosine, tangent values are concerned. Okay? So let's talk about radian measure, because radian measure is a measure of angle size. Same thing as degrees. Well, the same way that degrees measures an angle size, radians also measures an angle size. Right? And radians are usually given in terms of pi, right, with pi attached to it. Doesn't have to. You can see radians in whole numbers or decimal numbers, but most of the time they will be given in terms of pi. And you kind of treat pi as a variable in that sense. One of the benchmarks is that 2 pi radians is equal to a full circle 360 degrees. And if you divide both of those by 2, then you get pi radians, which is equal to 180 degrees, right? These are two benchmark values. Right, to convert from degrees to radians, most of the time if you need to do that, then you will be doing a problem that needs the angle size given in radians. So you will usually get the degree value and then convert it to radians from there. In order to convert from degrees to radians, you're going to multiply your degree value by pi over 180 degrees, pi over 180. So if we look at 45 degrees, 45 times pi over 180 is equal to, we can cross cancel here, 45 divided by 45 is equal to 1. 180 divided by 4 is equal to 4. And we get pi over 4 radians as our answer. All right, let's look at another example. 300 degrees, we want to convert this into radians. Take 300, multiply by this ratio of pi over 180. And 300 and 180 are also reducible by a factor of 60. 180 divided by 60 is equal to 3, so 3 goes on bottom. 300 divided by 60 is equal to 5, so 5 goes on top. And 5 pi over 3 is the amount of radians that is equivalent to a 300 degree angle. More important, well, I wouldn't say more important, but also equally as important is conversion from radians to degrees. There are many, many problems that will ask you to find, for instance, the sine of pi over 6 radians. Right, so in order to get our bearings, in order to draw these angles correctly, we're going to need to multiply by a ratio of 180 over pi. Right, so we'll start with pi over 6 radians, multiplied by 180 over pi. And what I said about pi is that it can be kind of treated like a variable, which means you can cross it out on top and bottom. We can divide, we can reduce 180 over 6 by a factor of 6. And that's going to be 30 up top, 1 on bottom. So we end up with just 30 degrees. All right, pi over 6 radians is equivalent to 30 degrees. So what if your radians are given in, let's say 2.5 radians, or 2 radians, or some other number? Well, the conversion is the same way. 2.5 radians times 180 over pi. This essentially means that we're just going to have a decimal answer. So let's take 2.5 times 180. That's equal to 450 divided by pi. And you can leave your answer like this, or if you want to put it in decimal form, we can divide 450 divided by pi and get an approximate value of 143.24 degrees. So let's look at again another example, this one with a pi, because that's where you're going to see more of your examples that you need to convert. 7 pi over 3 times 180 over pi, which is our conversion rate. And once again, pi over pi is going to cancel out, and 180 divided by 3 is equal to 60. So our result here is equal to 7 times 60, which is equal to a 420 degree angle. All right, and that's the angle that we saw previously on our coterminal angles, 7 pi over 3 radians. Thank you for watching.